In this movie, we're going to look at some more complex conditionals. So far, we've only seen what happens with a simple if statement. And we put our condition in, we put a statement in to be executed if the condition is true, and then any other commands we put here are going to be carried out regardless of anything to do with our conditional. What if we wanted to allow PHP to go down two different paths? One if this condition is true, and one if the condition is false. We use the else statement. This allows PHP to follow this path if this condition is true, but we have an alternative here which allows us to have a statement that will only be carried out if the statement is not. So let's try that, see it in practice, and let's set this number here to 2, and let's refresh the screen. Not more than 5. So in our example, this was the statement that was carried out, and this statement was not. So we can see here that PHP made a choice based on this condition and went down this path and not this one. Now, we can make it more complicated still. For instance, the elseif command. This can be written two ways. We can either write it as two separate words, which is perfectly acceptable, or we can run it together as an elseif command. Whichever way you choose is completely up to you. Now when we use our elseif command, the if statement here works just like the first if statement. We use the rounded brackets after it, and then we put in another condition. So in this case, it's going to be if num equals 5, then we'll use a statement that makes sense here. For instance, equals 5. And then we put another, we close that statement there with another curly bracket there. Once again, we could put any number of statements here, such as yes, it does, for instance. Of course, we could use different kinds of statements, just using the echo command because that's the only one we've learned so far. We'll get into more complex commands later on. Now, after that, we could just use a plain else. And logically, if num is not greater than 5 and is not equal to 5, then it's probably less than 5. So, let's try this one out. Let's see what we get. Less than 5. And of course, if we start with different values for num, we'll get different outcomes. Equals 5. So we can see in this example how our if statements can be quite clever and allow for quite a different number of outcomes based on, in this case, the value of a variable. We can get more complicated than this. Let's go back to here, cut that out, and what we can do to allow for a more complex system of conditions is what's called nesting if statements. Now this is where the indents come in really handy so that we can see exactly what we're doing. As we saw in the example I've just wiped out, each of the statements here was indented. Now this is not strictly necessary for PHP to carry out the code properly, but it helps us as human beings because we can then see a clear distinction between the conditions here and the statements which PHP will choose depending on whether they're true or false. But here's where the indentation really comes into its own. If we were going to nest two if statements, what nesting means is we put one if statement inside the curly brackets for another. So in this case, if num is greater than 5, then we evaluate this if statement, which says if num is greater than 10, we're going to open another set of curly brackets, and then we're going to indent twice, and that's going to say more than 10. And then we can put an else command in there, and we can say more than 5 but less than 10. Now, first of all, let's save that. Now let's see how PHP works through this script and gets to where it should be. Say if we took the number 7, then it gets the first if statement here, evaluates it to true because it's greater than 5. It gets the second if statement, looks at that, is 7 greater than 10? It says no, so it's not going to carry out this statement. It goes down to the else statement here, and it's going to carry out this one because it's greater than 5 and it's not greater than 10. So let's test that out, make sure it works. There we go. That's our first nested conditional script. Once again, I recommend you try these out yourself and get to grips with exactly how they work, and try making your scripts, try making your conditions as complicated as you like. If it stops working the way you expect it to, then strip it back and simplify it, but just get the feel of the way these conditions work and see how to script them for yourself before we move on to the next. There is another command that we use in PHP as an alternative to the if and else statements to carry out complex conditionals. This is called a switch statement. Let's take a look in our script. We'll start with exactly the same variable declaration, and then we're going to use the switch statement to do something similar to what we've been doing before in a slightly different way. We use the switch statement, and then inside the round brackets we put num. We don't put any other conditions, we just put it on its own, and then we open up our curly brackets. And then we use a command called case, and then straight after that, no brackets, we put a value that the variable might be. So for instance, case 5. So what this is saying is, if num is 5, then carry out this. So in this case we say num is 5. Then we use the statement break with a semicolon. You'll notice that after case 5 we put a regular colon, not a semicolon. This is a way of saying that these statements that follow it are dependent on this condition being true. We can put another condition straight after the break. What the break does is the break is a way of saying stop evaluating these conditions, such as case 5 and case 10, stop evaluating them and skip down to the curly brackets that are going to come at the end. So if case is true, then it carries out this statement, echoes num is 5 to the browser, goes to break, and falls off the end. Okay. Case 10, I'm going to say echo num is 10. It's a good idea as well, something I forgot to do, to indent these. Then we can see what's happening. And lastly we're going to put a case 7, so if num is 7, which is what it is, then we're going to echo num is 7 to the browser, and that's our lot. So we save that, and then we're going to take a look and make sure that works. Num is 7. So as we saw before, it evaluated num, checked what value num had, and if it was 5, then it would do this, but it wasn't, so it went down to the next one. If it was 10, then it would do this, but it wasn't, so it went down to the next one. If it was 7, and then it carried out these statements. Forgot the closing PHP tag there. Okay. There is another statement that is involved in the switch conditional, and that's called the default statement. Say if we chose a number that was neither 5, 10, nor 7, say if it was 36, then we could simply keep adding case statements here in order to account for all possibilities. But that could get rather tedious. So instead, we can simply put in a default case, which is what happens, we put that at the end of all the other cases, and this is what happens if all the others are untrue, and it really doesn't matter what num is, this following statement will be carried out. So we're going to say m is not, the num rather is not 5, 10, or 7. Let's save that, and we'll check in the browser, see if it works. So we refresh, and as we can see, it's chosen this statement. So it's checked this statement, this statement, this statement. They've all been false, so it's gone down to the default, and it's carried out this one. Now, you may notice a certain similarity between the if statements, if and else statements, and the switch statement. And you may be wondering why there are so many different ways of doing similar things. The answer is that as you develop more different kinds of scripts, and you have more different kinds of choices that have to be made within your PHP scripts, you'll find that switch statement and the if and if else and else if statements all have their own uses in which, for the reasons of it making it clear to the reader, it's easier to use switch or if. To the computer, it makes absolutely no difference. and you're completely at liberty to use whichever you like. I'm just showing them all here so that you get a good idea of the comprehensive range of ways that PHP makes decisions. There's just one more left. That's a very concise little one and very useful, and we're going to find out about that in our next movie. And now we're going to look at a different way of making decisions, which is not even a statement, but an operator. Now, operators, as we saw before, were the little symbols that PHP uses to express different kinds of conditions, or rather that we use to express to PHP what we want it to do. So let's have a look at, first of all, we're going to do this condition the way we learnt before, using if, and an if and an else clause. Now, that seems a fairly concise way of putting it, and we're going to set our num up here. Okay, so you should be able to work out what this one does. We've seen quite similar things in the previous movies. If the variable num's value evaluates to 7, then we echo exactly 7 to the browser. In all other cases, we echo, I've put a little typo in there, not 7. Okay. Now, there is a conditional called the ternary conditional, which is a very concise way of expressing the same thing, all in one line. Now this may look a little intimidating because it's a lot more concise, but don't be scared. You don't need to use it right off. Just use the if statements until you get completely happy with it, and then later on you'll see why it's such a useful way of writing things. So we start off with our echo statement. This is a completely different way around of working, because in this way round we write the condition first, and then we have to write 2 echo statements here. But this way, we write the echo statement, and then inside brackets here, we put the condition. So if num equals 7, then we use a question mark. And this is the first half of the ternary operator. And what that means is it's exactly the same as an if statement in the way it works. And we type in what we want to echo to the browser. If this condition is true, we type in here. Then we put a colon, not a semicolon, a colon. And then we put in the else condition afterwards. So it works very much like an if-else condition. And let's take this out, because we don't need this. Now this one line of code does the job of those 5 lines of code we had before. Let's save it, make sure it works. Not 7. And the value that we chose in this case was 8. So our little ternary condition, very concise, but it works just fine. Let's have a little look in more detail at the way it works. First of all, we have the echo statement, or whatever command we want to use. And then instead of simply writing the text to be echoed straight after it, we put in this condition. And that's a way of telling PHP that, hold on a minute, don't echo right now. First of all, evaluate this, and then based on that, choose which one of these you're going to put in there. It's as if this text is swapped in place of this condition. Either this text or this text. So this question mark is like the true side of the operator, and this colon is like the false side. So if it's false, or the else. A ternary operator is expressed like this, but we never see it just like that. We always see it within the context of a line. Now this can get really useful when, for instance, we have several if-else statements, and say if we wanted to put in our else clause here, if we wanted to put another condition, this is a way of simulating an else if, but again, all just in one line. We put another condition here, and if that's true, then we move on to this one, and if not, we move on to that one. Again, we use the colon there for the else, and then a little semicolon at the end. Let's save that and make sure that that works. More than 7. And 8 is more than 7, so our little script must be working. I'll just go briefly through the way this works. This beginning bit works in a similar way. We get to the echo statement, and this conditional says, wait up, evaluate me first, and then see what text you want to swap in. So first of all it says, is this true? If it's true, then we want to swap in exactly 7. The value is 8, so it's not true. So we move on to the second part of the first ternary condition, and it wants to swap something back into here to be echoed, but it only finds another condition. So you're going to have to wait a little bit longer. The echo condition is going to have to wait a little bit longer to get its result, and the condition this time is if num is greater than 7. And if that's true, as it is in this case, then it prints out this, and if not, then it prints out that. Now, needless to say, this takes up a lot less space than writing, let's see, how many would we need? We need an if statement here, and then an else if, and then another else. So that would work out to about 7 or 8 lines of code. So we can see that the ternary operator is a very concise way of expressing conditions in a PHP script. As I said before, if you don't understand how the ternary operator works, or if you find it too intimidating, this concise way of coding, don't worry. You don't need to use it right now. Just play with the if statement, and if you find this useful, by all means go ahead and use it, but you can write script as complex as you like and never have to use a ternary operator, or never have to use a switch operator either. Once again, it's a matter of personal preference, and go with what you like. So that now wraps it up for this chapter and conditionals, and in our next chapter we're going to look at more complex control structures and ways of repeating and iterating elements within our PHP scripts. In this chapter, we're going to learn about loops and control structures. This will provide us ways to repeat commands within PHP without having to type them again and again. We'll be able to set up loop structures whereby PHP will repeat a certain set of commands as many times as we define in our script. First of all, we're going to look about repeating commands using the for loop, and then the while loop, and then we're going to look at another kind of loop known as the do while loop. Then we're going to look at escape commands, such as break, which we touched on briefly in the last chapter, and exit, which allows us a way of escaping completely from our PHP script. Let's take a look at our text editor and try a for loop. Now the command for is the one that we need to carry out this kind of loop. We just type that in, then we put some conditions within a pair of normal brackets, rounded brackets. Then we put the commands in here, whatever commands we like within curly brackets. And that's the basic structure of our for loop. It may look a little like an if statement, but we'll see a difference now. Let's put in some of these conditions in our for loop here. Basically, there are three statements that have to go as the parameters for the for command. The first of which sets up an initial value for a variable. Typically, it will be something like this. Variable I is set to 0. Our next statement will give a condition for the loop to continue being processed. So in this case, variable I is less than 6. And the third and final statement in the parameters for our for command is something that is executed every time. You may remember this increment operator, ++, from a previous movie. What that does is it adds 1 to I. So every time this loop operates, 1 will be added to I. So let's put in a simple command here. We use the echo statement again, and we'll just echo the number, and let's put in a BR tag, an HTML tag. Notice I use quotes to enclose that, and I use the little dot there which tells PHP to run these two together, the concatenation operator that we learned about earlier. And I put a semicolon at the end. Let's save that, and we'll save that as first for loop.php. Okay, let's go to our browser and we'll try that out. Don't worry if you don't understand what the script's saying right at present. That's fine. We'll just see how it works and we'll get into more details when we've seen this. Okay, our for loop prints out the numbers 0 to 5, and it puts a break in between each, meaning each of these numbers is on a separate line. So effectively, this command has been carried out 6 times. But each time, this has a different value. Now, why is it that it goes from 0 to 5? Didn't we say 6 would be the maximum here? Well, not quite. This command, or this statement rather, is the condition by which the loop will continue to be processed. So when I actually gets to 6, it's no longer smaller than 6. So the largest number for which this is still true is 5. That's why we went from 0 to 5. Now, we can change any and all of these statements. We could start at 12, for instance. We could continue up to 24. And we could, maybe we don't want to add 1 to I every time. Maybe we want to add 2. We're using the combined operator here to add 2 to our variable every time. Let's save that and see what that does. Same number of numbers shows up, but they're very different numbers. It starts at 12, as we specified, and it goes up by 2 every time, and we said less than 24. So it got to 22, it added 2, and that was 24, and so this condition was no longer true, and so the loop exited, and we got to the end. So that's a for loop. Now there's one thing further I want to say about loops in general, and for loops are no exception, and that is that as we program, we need to be very careful that we give a proper closing condition. What I mean by that is, we have to make sure that our loop will eventually exit. What we want to avoid is the infinite loop. For instance, in this case, I will eventually no longer be less than 24 because this is going up. However, what if we replaced this with this combined operator? If we wanted to reduce the value of I by 2 every time. Well, let's have a look. We'll see what that does. We'll go back to our browser and refresh. That's thinking for a while. Oh, and here it comes. And as we can see, it goes down quite a way. It's reducing by 2 every time. How far does it go? We can see minus 20 down there. When I'm trying to drag down, the browser becomes quite unresponsive, and we can see here that the numbers are getting quite, well, they're not big, they're very, very small. They're negative numbers that are getting way out of hand. In fact, as we can see from this scroll bar, look at the size of that scroll box there. This HTML page is getting huge. We better stop for the sake of the computer's blood pressure, and we'll scroll right down here and see how far it got. It got right the way down to 161,918, and that's a negative figure, as we can see from that minus sign there. So it was going quite a way, and it was only because we pressed the stop button that it ever stopped. Otherwise, it would still be happily trying to process more values for I. Now, why did this happen? This wasn't what we meant. We didn't want to end up with a huge page of HTML like this. Let's have a look at our script. Our starting condition started I at 12, and every time the loop executed, I would be reduced by 2. So that looks like it should work. What's the problem? The problem is this closing condition. This condition continued to be true and would continue to be true forever, because since I was being reduced continuously, it was always less than 24. Minus 161,918 was definitely less than 24, and no matter how much you took away, you would continue to have a figure that was less than 24. So there's an example of an infinite loop and the kind of thing that we'd want to avoid. We could easily remedy this, of course. We could say greater than 0. Let's take a look at that. Refresh our browser. This time, much more sensibly, starts at 12, takes 2 off every time, and it stops very conservatively just before 0. So we fixed our infinite loop problem. I hope you can see what I mean about the dangers of infinite loops. I suggest that you take some time to play around with for loops, make some of your own, before we go on to our next movie and you learn about while loops, which do a similar thing. Now let's have a look at the while loop. The while loop is quite similar to the for loop in what it does, but you'll be pleased to hear that it's even simpler. So let's set up our first while loop. How it works is very similar in syntax to an if statement. we use the while command. We have some conditions in there, and then we put some command within curly brackets, just like an if statement. So let's say our condition is I is less than 6, and let's not forget our open PHP tag, and we've got to set a value for I before we start our while loop, that is. So in this case, the value we've set is 0, and we say while I is less than 6, we'll echo we'll use the same command as we did for the for loop. Now, at the end of our last movie, we learned about infinite loops, and here's an example of one. If we just left it like that, then that loop is just going to keep executing again and again and again and again, and there's no reason why I will ever be equal to or greater than 6. It will always be less than 6, and so this statement will just keep on executing forever. So what we need is something like that. Let's close our PHP tags, save this script, and let's see how that works. Exactly the same results as the for loop. Once again, you may be wondering why there seems to be different ways of doing very similar things. Well, different scripts call for different kinds of loop, and it's impossible to explain why there's a while loop and a for loop and other kinds of loops without looking at more complex examples, which we will do later on. But for now, it's important that you get familiar with all these kind of loops and try them out for yourself. Now there's another kind of loop, very similar to the while loop, which is called the do while loop. And how we do that, how we execute that, is we use the do command without any condition, and then we put our condition down here at the bottom with a while. So essentially we do these statements while this is true. Let's check this one out. Exactly the same. It does exactly the same thing. So you may be asking, quite reasonably, what's the difference? What's the point? Well, say if while started out as 32, what do we get then? We get 32. That's because we set the variable here, we get to the do statement, it carries out these commands, and then it checks the condition. Whereas with our while, our simple while loop, let's take this one off, that's the way our while loop is set up. Let's see how that manages with a starting value of 32 for I. We'll save that, and let's refresh this browser, and we get nothing. So what's the difference there? Let's take a look back at our script, and we'll see that I is set to 32, and then it gets straight to the condition while I is less than 6, and so it never carries this out, not even once. So the essential difference between the do while and the while loops is that the do loop will always carry out this at least once, whereas the while loop will only carry out this as many times as this is true. So that about wraps it up for while and do while loops. And in our third and final movie for this chapter, we're going to look at escape. Now we're going to look at two commands which allow us not to make loops, but to get out of loops, or to get out of scripts. First of all, let's look at the break command. Now, we touched on this very briefly in the context of the switch condition, and let's see how this works with loops. Let's set up a loop similar to the way we did in the first movie of this chapter. And this time we're just going to echo the number of I, the value of I rather, and then we're going to put in a condition here, which is an if statement saying if variable I equals, remember to put that double sign in for equals, 14, then we want to break. We close our loop, and once the loop's finished, we're going to put in another little echo statement reminding us at what point the loop ended. Okay, let's save that and see what this does. Refresh our browser. Goes from 0, adding 1 to I each time, and echoing I to the browser. And finally, it gets to 14. Then we see this line, loop ended at 14. So what happened there? This line allows PHP to escape from this loop, because if we see this condition up here, the loop is supposed to go on until 20. But we've put in an extra condition here that says when the loop is equal to 14, then we're going to ignore this for loop business. We're just going to jump straight out to the end, to the outside of this curly bracket here, and we're going to execute the next statement, which in this case is echo, another echo command, and it's going to tell us at what point the loop ended. So we can see that break is a way of adding conditions within a loop that allow us to get out. The other command I want to show you in this movie is the exit command. So let's take off those commands there. And I think the easiest way to show this is simply by using two echo commands, which will simply say this text will be shown. Then we're going to use the exit command. Remember to put semicolons at the end of all the lines. And then we're going to say this text won't. Let's save that and check it out in our browser. So, the only text that's shown is the text from the first echo statement. So as we can see, what exit does as a command is it effectively tells PHP to ignore everything below it. It tells PHP to stop processing this entire script and jump right down to this close PHP tag and stop. So there are two other control statements that we can use. Exit is slightly more drastic than break, but both are very useful, and we'll find uses for them as we start writing more complex scripts. That's the end of this chapter, and in our next chapter we're going to look at ways of manipulating data, which is what PHP and other middleware is all. In this chapter, we're going to be looking at the ways PHP stores and works with data. To begin with, we're going to look at arrays, which will allow us to store a number of values within one array variable. We're going to be looking at numerically indexed arrays, associative arrays, which allow us to give names to each element within the array, and multi-dimensional arrays, effectively arrays of arrays. Then we're going to look at some string manipulation, the ways we can work with strings within PHP. And finally, we're going to look at regular expressions, ways of checking strings against a pattern of numbers, letters, or symbols. So let's start out and look at an example of an array in PHP. We declare our array the same way as we declare any other variable. In this case, we're going to use an array containing all the names of a pop group, let's say the Beatles. And instead of just putting one value on the other side of the isSet2 sign, we're going to write the word array. Then we open brackets, just a normal rounded brackets, and we're going to put in a number of values separated by commas. And there are the surnames of the band members. Now, what this command does is it stores all of these values within this array. That way, we can reference each of the values by referring to the array itself and a number. So, this is the first, that's the second, this is the third, that's the fourth. However, it becomes a little complicated because PHP's arrays don't start with the number 1. They start with the number 0. You'll find this to be true in a lot of other programming languages, and you'll probably be used to this if you've done any programming before. But if you're not, the thing to remember is simply that arrays are 0 indexed, which means that in this case the element Lenin is not the first element, is not element number 1, it's element number 0. So when we come to reference our array, let's say we wanted to pull the first element from that array and echo it to the browser. We use the square brackets here to let PHP know which element we want to, where we're dealing with here. And we're going to put the number 0 in like that. Now let's see how that works. We'll save that, pop to our browser, and take a look. Lenin. So here it's interpreted the number 0 and looked at element number 0, which would be Lenin. If we took element number 3, save that and refresh our browser, then we see star. Let's take a look back here. Now we see that star is in the 4th position on the list, but we've said echo Beatles element 3. Now of course the reason for that is if Lenin is 0, then that makes the second item number 1, the third item number 2, and the fourth item number 3. Now that may take a little getting used to, but it will prove to be very useful later, as we'll see, and it's just one of those things in programming that is well worth getting used to. That'll do for that movie. In our next movie we're going to look at ways to reference all the elements within an array. Now we're going to have a look at ways to reference all elements in the array. The good thing about arrays is that because they all have the same array name, but just different element numbers, we can set up a loop and reference every element within that array. Let's use a for loop to try that. We'll use a very similar one to the one we used when we introduced for loops in the last chapter. And we're going to start at 0. This time our array, you may have noticed, is a slightly different one. We're sticking with the Beatles theme, but this time we're on Beatles albums. And our first Beatle album is Please Please Me, and that's in element 0. It's the first element of an array is element 0, so we're starting at 0, and we're going to use as our continuing condition, the middle condition of our for loop, is going to be variable I is less than 4. That's because the last element is 3, and 3 is the last number that's less than 4, because for itself that condition wouldn't be true. And we're going to go up by 1 increment each time. And let's say we echo album number is, we're using the little concatenation operator there, and we're using variable I to keep track of what number album we're on. Of course, this has nothing to do with the Beatles output. This is simply an arbitrary collection of albums that we may have. And then we're going to put after another concatenation operator, we're going to write the albums array, and the element will be I. And after that, let's put in an HTML break tag so that each element has a separate line all to itself. Close our curly brackets, and away we go. Let's take a look and see what that does. Refresh our browser, and here it's given us all the elements of our array, and that's worked very nicely. However, what happens if later on we come back to our PHP script and we've bought a new album? We're going to pop that on the end of our array. Let's save that, and then we're going to try and run the script again, and what's going to happen? Whoops! For some reason it hasn't noticed that we put a new element in our array. Why was that? Let's take a look back here. Reason is that we've got the same condition in the middle of our for loop, which is variable I is less than 4. So it only works with 4 elements, because once we get into the 5th element, which is, because of our 0 indexed arrays, element 4, that's no longer less than 4. We need to bring this up to 5. Now, that works fine for this little instance, in which case we've just made one change here, but in terms of programming practice, it's a bad idea to have to change our for loop every time we add an element to our array, particularly as we get on to details within more complex integration with back-end systems in which we're referencing databases, and maybe we won't know how many elements our array is going to have. So we need a way of making our for loop flexible to count as many elements as are in this array. To do this, PHP has a special inbuilt function called count. So instead of 5, we're just going to put in count albums, variable albums, just like that. Let's save that. And we'll check that one out. And yep, it's got all of them. Just to show how that works, let's say at the end here, we echo let's save that and take a look at our browser and refresh that. And as we can see, the number 5 is what this outputs. It counts each element within our array and it returns that figure. You'll notice that it returns the figure 5 even though this is 0 index. The reason for that, it's not returning the number of the top element, it's returning the number of elements altogether. That's why, so long as we're starting with 0, the top element will always be 1 less than the count of the full array. That's why we can use this as our middle condition on our for loop. One more thing we can learn about arrays before we move on to associative arrays is the sort function. This allows us to sort our albums array alphabetically. That's the syntax for the statement. Just use the function name sort and we put the array within these normal brackets here. Let's save that and see what that does. As we can see, alphabetically sorted help, then let it be starts with an L, please, please me. As we can see, that's alphabetically sorted. So that's our sort command. There's a very similar command known as rsort, and what that stands for is reverse sort. So that'll sort it in backwards alphabetical order. So if we save that with the albums array rsorted, reverse sorted, then we go back here and we refresh, we'll see that the array has been sorted the other way up. So Sgt. Pepper's goes into the first slot, revolver, please, please me, let it be, and help. So those are two very useful little functions. However, there is one more thing that needs to be known about the sort command and the rsort command. Let's change that back to sort. And let's put in some values which can show the slight complication to sort, which is that it's case sensitive. So capital A will come before capital Z, but capital Z will come before lowercase a, for instance. It's easier to show you what I mean if we type in some examples here. We just take some upper and lowercase words and choosing A and Z because they're very easy to get. Now we have here, the order so far is capital A, followed by the word beginning with small a, then a capital Z, and then a small z. Intuitively, we would expect them to stay roughly in that order, or maybe put the alo before Amina, and Zebedee would stay before Zest. However, because of the case sensitivity of sort and rsort, we're going to see that something slightly different happens. Let's save those, and let's refresh. As we can see, the capitals come before the lowercase letters, regardless of what they are. So it'll go capital A, capital B, capital C, and then finally, after all the elements that start with a capital letter are over, then it's going to start looking at the lowercase letters. That's something we need to be especially aware of with user input, where we can't tell whether the user is going to use a capital letter or not. So we've learned about referencing arrays and sorting arrays, and now we're going to look at a different kind of array called the associative array. So far, we've only seen numerically indexed arrays. These are the kind of arrays that we can refer to each element by a number. An associative array, on the other hand, lets us give a meaningful name to each element within it. Let's say we wanted to store a number of greetings in different languages. We could set up a greetings array and simply include all the greetings as numeric elements within that array. And then we could reference it by saying greetings element 1, for instance, which would be the French in this case. However, this is not a very useful way for us to reference such an array, because the numbers 0, 1 and 2 have nothing to do with the content. That is, a greeting in English, a greeting in French, and a greeting in Spanish. It would be a lot better for us to be able to specify the language that we want as the element. Well, there is a way to do that, and it's known as the associative array. How we do that, we simply put in the names that we want to give our elements. Then we use this symbol, looks like a little arrow, and then we put the value. And the names we give our elements are known as keys to separate them, to differentiate them rather, from the values. So in this case, the key is Spanish and the value is dígame. In this case, the key is English and the value is hi there. So when we come to reference our associative array, all we need to do is type in the array name and put the square brackets in, and within those square brackets we put the name of the key that we want. So if we wanted to output the French greeting, we simply use this syntax. Let's take a look at our browser and see how this works. Salut. It's picked out the greeting that we wanted based on the key that we put within these square brackets. So if you put English or Spanish instead, it would output the response in the appropriate language. So we can see that associative arrays are a much more flexible and meaningful way of naming the elements within an array. And both numerically indexed arrays and associative arrays have their uses, but there are drawbacks and advantages to both. One of the problems with associative arrays is that we can't reference every element within them simply by taking a number, as we did with our numerically indexed array in the last movie, and increasing that number and using that to reference each element within the array. The reason for this is that numbers are not involved within associative arrays. Each element has its own text name, so we can't just use a counter. So how do we do that same thing with an associative array? The answer is there's a special function known as the each function. Now let's say we set up a variable called current greeting, and we'll set that to each. This is the each function. Each greetings. And what that does on its own is it takes the first element it comes to and it outputs an array which we've called current greeting, and this is also an associative array. But this associative array has only two elements, and those are key and the imaginatively named value. Don't need another break tag there because that's the last thing we're going to echo to the browser. Now you may be looking at these elements here, key and value, and saying, now where did you get those from? Because nowhere in the script have we initialized any array which contained these as the keys to an associative array. Well, actually we did. How we did that was using the each command, which outputs just such an array as whatever name we gave it. Now by default, this each command will go through the array and check each element of greetings one by one. Because we've only said to do it once, it's only going to get as far as the first element. Let's take a look at our browser, and we're going to refresh that. As we can see, English is output, and hi there. Taking a look back at our script, that means it's output key and value. The key being English, and the value being hi there. So we can see that this can be quite useful when we come to want to look at every element within our greetings array. How we can do this is by simply making this into a while loop. And we're going to have to put in that other HTML break tag there, because now it's going to happen more than once. And the reason why this while loop will take us through every element is that it's going to carry out this every time, and the first time it's going to look at this element, then it's going to look at French, then it's going to look at Spanish, then it's going to try and look for the next one, and it's not going to find anything. And so it's going to set this current greeting array to empty, nothing, null. And therefore this while will evaluate false, and it will skip to the end of the curly brackets, and this will stop executing. So let's take a look at that in our browser. As we can see, it's output each key and then each value one by one. Now this may seem like quite a complicated way of simply pulling the values out of the array. Well, it is. And unfortunately, with associative arrays, because they're more flexible, we have to do slightly more complicated things to get the data out of them. However, there is another way of doing it, which allows us to give slightly more meaningful names than current greeting key and current greeting value. How we do that is by using the list function. If we do that, we can take out this array here and simply put in two variables So instead of outputting an associative array, it's just going to output two variables each time. Let's call them language and greeting, singular. Not greetings, which is the name of our associative array, but greeting, which is just going to be a simple string variable. We have to make sure that we put these the right way round, because this is going to be key, and this is going to stand instead of value. So we can pop in language here and greeting here. So we can see that by using the list function, we simplify things quite a lot. The reason I showed you the way without it was so that you could see how the each function actually works and appreciate what it's doing there. So let's turn all of this into something useful. We can say in concatenation operator, then we can put a comma in and a space. We say we can put our greeting in, and maybe let's put in some quotes around the greeting. Now it's very important when we're putting anything within our double quotes, we don't use other double quotes, or if we do, we can escape them using the backslash. We're not going to learn about that yet. We're going to learn about that a little later. So let's just put in single quotes for now, and we're going to put in a single quote there. Those single quotes means that PHP is not going to get confused, think that we've somehow exited our double quotes when we haven't meant to. So let's save that. We're going to pop back to the browser and see what that outputs. In English, we say hi there. In French, we say salut, and so on. So as we can see, using the list and each functions, we can reference every key and value within our associative array. I suggest that you take the time to get comfortable with associative arrays and play with making them and using list and each to reference the elements, because that's quite a lot to digest, and you should practice it for yourself before we move on to our next. We're going to look at a couple more things that you can do with arrays in this movie before we move on to multi-dimensional arrays. We looked at sorting arrays earlier on in this chapter, but we're only looking at numerically indexed arrays. When we come to sort an associative array, we have two options. We can either sort by the keys, or we can sort by the values of the associative array. And the functions that carry out these two different kinds of sorting are ksort and asort. And asort will sort greetings, the array greetings, by the values rather than by the keys. So let's save our file and have a look. As we can see there, the order that it's put it into is alphabetically by the value of each element. So D comes before H, comes before S. If we wanted to reverse that, we'd simply use the AR sort. Let's save that. Take a look back at our browser. We can see it's reversed it this time. S, as the latest in the alphabet, comes first, followed by H, and D, the closest to A, comes last. Now ksort, which sort by the keys, allows us to sort our array alphabetically by the names of our keys. So in this case, English will come first as the E, then French, because F comes after E, and then Spanish. Now, similarly, we can use KR-sort to sort our array reverse alphabetically by the keys. So Spanish would come first, then French, then English. I won't bother to show you that. One more thing I want to show you about arrays is how to add or to alter an element in an array after we've already declared the contents of the array for the first time. We can use the square brackets similarly to how we reference the array to add or alter to the contents of the array. So in this case, let's add a language, Bengali, and we'll put the value on the other side of the is set to operator. Ki khobor. So that's added a language. Now let's see what that'll look like in our browser. So it's added a language, added an element, and because we've used the K-sort by keys, B, which comes before E, has been set to the first element. It works very similarly for a numerically indexed array. Let's take all this out, and we can say a simple numbers array of 1, 2, 3. Although I say numbers, we're using words really. The words happen to be numbers. And we can say that numbers, now so far we've got elements 0, 1, and 2. So let's say numbers 3 equals 4, just to be confusing. And then we'll use that same little for loop to run through our array and output all the elements. Let's save that, and we'll return here 1, 2, 3, 4, and let's put them in without spaces. Oh well. But as we can see, we added an element here, and it allowed us to add a completely new element onto the end of our array. So if we change this to element 0, what would happen there? Let's save our script, pop back to the browser. As we can see, instead of adding 4, adding the word 4 to the end of the array, it put it in place 0, and so we have 4, 2, 3. It's because we used the index 0 to specify which element we were referring to. So we can see it's just as easy to add and to alter the contents of an array as it is to reference it using the square brackets. So there's some final things about arrays, and in our next movie we're going to take a look at multi-dimensional arrays.